Hi, I'm Shannon Appelkline. I'm a technical writer here at Blockchain Commons, and we have all frost all morning for you today. So I'm going to start out with a kind of introduction, highlight it. Some of it's going to probably be stuff you already know, but hopefully there's a few little insights in here as well. So here's our usual bit on blockchain commons, but seen through this lens, Frost is about letting people control their digital destiny through a signature system that can enable control of digital assets, group coordination, and more. And it's very much part of our collaborative work with the community because it's not something we created. It's something that was out there, that was being worked on, that was so cool that we really wanted to throw our support behind it as well. And I should say thanks to HRF, the Human Rights Foundation. They gave us a generous grant to implement this technology, the work that Wolf's been doing for much of the latter part of the year, and this course that I put together. So, what is Frost? Frost stands for Flexible Round Optimized Schnorr Threshold, and that hits most of the key points. It's a threshold signing system that uses the Schnorr algorithm. There's a bit more than that, but the other particularly important point is that it's designed to integrate with distributed key generation. I'm going to go through those points one by one to give them all a little more detail. So, signatures. Digital signatures allow you to verify messages. Those messages could be board minutes, a publication, or in order to move digital assets, which is a lot of where we've seen them used so far. With a signature, you know who signed the message, and you know the message hasn't changed since they signed it. Note that signature doesn't mean encryption. They're separate uses of cryptography, and Frost is all about signing. So multi-sig, we all know that's a special type of signature that allows a group of people to all sign together. A threshold signature is a multi-sig where a subset of the group can sign for the group. So I have that labeled here as M of N, where a subset M of a group N can sign, not all the people. Okay, so Schnorr. It's a particular signing algorithm. It's got a different foundation than some traditional signatures like RSA, REC, DSA, but I'm not going to get into that. What's important to know are the advantages of Schnorr signatures, and the big one is that they're aggregatable. You can add together my signature and your signature for a multi-sig, and what you get out of it is totally indistinguishable from a single signature, which also means that it's the same size as a single signature. Okay, so the last puzzle piece of Frost is distributed key generation, or DKG. Frost signing is done with what are called signing shares. They're essentially shares of keys, a threshold of which you bring together to sign. You could have one person create the key and shard it. That would be a kind of old-fashioned way to do it. It's called trusted dealer. But you can also use multi-party computing to engage in a ceremony where everyone exchanges information, with each party getting their signing share and a shared public key. But the full private key it's never created, which is some pretty powerful security. Okay, you might already have some hints from those descriptions, but let's talk about why you would use Frost, especially over other signing systems out there. Bitcoin, of course, has its classic multi-sig algorithm, which can be used to authenticate Bitcoin transactions. It uses pay-to-script hash with the check multi-sig opcode. Everyone can see that a Bitcoin multi-sig has multi-signers, and each signer increases the size of the transaction. In contrast, Schnorr signatures for Bitcoin transactions use pay to taproot, and they look exactly like any other signatures. That's thanks to aggregatability. So people don't know it's a multi-signature. Its size never changes no matter how many people sign it. As it happens, you also can't see which members of a Frost group signed, just that enough did, which is a nice benefit if privacy is important to you. There's another Schnorr-based signature scheme that has quite a bit of usage called Musig 2. There's two big differences between the two. First, Frost is a threshold system, while Musig 2 is just an in-of-in multi-sig system. Thresholds are possible using Merkle trees, but it's a bit of additional work. Second, there's a contrast, which is Frost has the characteristic of privacy that I mentioned, Well, Music 2 instead has accountability. You know exactly who signed. This is one of those cases where you're going to probably pick your signature system based on the particular needs of your use case. So here's a look at all three signature methods in a chart. Um, I think the really important thing here is the size. You've got 64 bytes for Schnorr signatures, period. Well, classic ECDSA for Bitcoin, it's 72 bytes for every signature. Now, obviously, that's going to be a difference in what you have to pay for a transaction if two or three people are signing. But imagine a situation instead where you have a group of 150 people and you want a quorum of 100 of them to sign. There's no way that's possible in traditional signature systems, but it's totally doable with Schnorr. So here's a quick summary of all of the advantages of Frost. There's two of them that I hadn't mentioned yet. One is that the Frost protocol is built to have efficient communication. I'm going to show you what that looks like in a second. The other is that it has refresh and repair capabilities. That last bit means that you can regenerate lost shares, you can increase the number of signers, you can change thresholds, and you can generally update your Frost group in a lot of different ways after the fact. In a classic multi-sig system, you would have to, say on Bitcoin, sweep your funds to do something like that. And you don't have to here. You can just redo the signatures. This is a bit more bleeding edge than some of the other things, but I've seen real working prototypes of it in an actual working wallet. Okay, so how does Frost work? This is the part that I'm not going to dwell on too much, but I wanted to briefly show you a little bit of what its communication mainly looks like, because it's good to have a handle on the overall system. It comes in two parts. You have the key generation, where you make your secret shares, and you have the signing, where you use your secret shares. And as it happens, there are two different ways to do each of those, which is a total coincidence, but I'm going to run you through all four, and then I'm going to show you all four very quickly from the command line. Okay, so here's Trusted Dealer. As I said earlier, a single person creates and distributes a key. It's a simple process, but you have to actually trust the person, and I mean really trust the person doing the work. The key exists in a single place during key generation, and could continue to exist there if the trusted dealer doesn't delete it like they're supposed to. So it loses a lot of the advantages of Frost, but maybe it's the only way you have to do it, and you do get those advantages down the line if the trusted dealer does what they're supposed to. All right, here is distributed key generation. It's the better way to generate keys. It's typically called a two-round process, but you can see the prep at the top, which means that you actually have to do some out-of-band setup to decide your group size and your threshold. In the actual ceremony, you create secrets and publicly commit to those secrets. That's round one. And then you privately you calculate your signing shares, and then you privately to each member commit to those shares. Again, we're not going to dwell on the specifics. The most important thing to note here is that you have to have communication channels. There is a broadcast channel and there are private channels, and how those work are kind of beyond the scope of Frost itself. And you have to figure out how is this going to work. And we're just going to show you later on how this can work in a very private, decentralized way. Okay, so here's signing. Note that this time not only do we require communication channels, but we also have a centralized coordinator. They don't know any secrets, they don't learn any secrets, but they could block the whole process if they wanted to. So they're not exactly trusted, but they're semi-trusted. As for the actual process here, it's the same type of thing. We're creating secrets, we're sharing commitments to those secrets, and eventually we're signing the message, and then the individual signing shares are aggregated together. Though it's the Frost signing is fundamentally a two-round process, as I just showed you back there. You can actually pre-process one of the rounds, and you do that by creating a whole slew of secrets, by creating commitments to those secrets, and by maintaining all those commitments in some data store. A server is the way that the Frost paper suggests doing it. Um, there's a lot of different methods for how you could do it. Uh, the end result here, though, is Frost signing can be made more efficient and sped up a bit. Okay, so where can you learn more about Frost and get some hands-on experience to really see how it works? The answer to that is actually the foundation of what I presented here, which is it's the Learning Frost from the Command Line course. It's a brand new course funded by HRF. We've just released it on GitHub, and we now have it on a nice book-oriented web page as well, which is what learningfrost.blockchaincommons.com is. It's fully edited, it's fully drafted. We're seeking peer review, particularly to make sure that our descriptions of Frost and its processes are entirely accurate. We have a previous course that Christopher and I did called Learning Bitcoin from the Command Line. It's been very popular. We know that it's gotten people into the industry because we've worked with them. Um, Okay, so working from the command line means that we needed command line tools, and those came about due to Zcash's zfrost project. They have a repo on GitHub called Frost Tools, and it contains tools for trusted dealer generation, distributed key generation. It's got two different types of clients and servers, one of which is used for distributed key generation, and each of them can be used for signing in different ways. So a lot of tools and a lot of ways that you can really check out how Frost works and see all of the particulars. Um, we, and by we I mean Wolf, uh, have done a bit of work to expand their tools. We created a tool called Frost Verify Rust, which checks the particular file format of zfrost signatures so you can see that the signatures are actually working, which I thought was important for a hands-on course to make sure you knew that you could do a signature and that it then checked out. Uh, the biggest thing, though, was we wanted to show how could you use Frost for Bitcoin transactions. And so Wolf made several tools, a couple of helper tools, and then some uh, PRs for the actual ZF Frost tools to allow you to actually do a signature. And he's got a demo of that that he's done that we have videos of, and it also appears in the Learning Frost course. So we suggest you try out the course. Our From the Command Line courses, they've always been about providing hands-on experience because we think that's a really visceral way to see how things work and to get it into your memory. Um, but before I close out, I'm going to quickly run you through what does this look like? How does this work from the command line? So this is the ZF Frost Trusted Dealer tool here. It's very easy. You tell it a group number, you tell it a threshold, and it generates a whole bunch of packages, each of which has an individual signing share. So here's what one of those packages actually looks like. You can see it's got a bunch of related information. And again, this is why I like a hands-on course because you can create this type of thing and then see, oh, what do they need to do this work? But most importantly, it's got that signing share. So this is what people will use to actually sign when they're using Frost. So distributed key generation is, like I said, the alternative. And there's two different ways in the ZF Frost tools to do distributed key generation. This is their straight command line one. You again tell it your group size, your threshold, who you are, that's the identifier. And then it starts generating packets. And you have to, via some out-of-band means, pass these packets around to other people and enter them in, and you have to correctly identify where each packet came from, which round it's from, who it's from exactly. If you identify a packet with the wrong member, the whole process breaks. In other words, it's just begging for a better UI, and it's prone to errors without it. Um, and I say this knowing that it's prone to error because this is an example of Stack Wallet, which is the wallet I mentioned earlier that actually does all of the cool stuff with Frost. And this is an example of its initial DKG. And as you can see, it's set up exactly like that command line setup where you're getting commitments from various members and you're entering each person's commitment in. And first time I tried this, I screwed it up. I put in the wrong person's commitment or the wrong phase. I don't know, but I got all the way to the end of the process and it didn't work. Um, so that really shows how this type of thing where you're trying to do this by hand is not just prone to error, but it's one of the big stumbling blocks for using Frost. So we need to make it a lot easier. So how do you make things easier? Fortunately, the ZF Frost tools have examples of that too in two different servers. They're just you actually have to set up secure servers on the internet to use them, and so they're a little more challenging. Um, so this example, it shows the Frost D server, which is the easier of the ones to set up. Um, it routes the correct information to the correct people. It logs everything correctly. You could see the other, I was putting in all this information. Here it just does it all for you when you enter the initial information. Again, the server is semi-trusted. It could block the process, but everything's end-to-end encrypted, so it doesn't see any special information, and the signing key still never exists in one place. So this is increasingly what we want to see for the UI of Frost to make it easy for people to use. So I should stop and note here that though we can start to see solutions for the UI of Frost, we're still going to have all of the typical issues with key management that we've always faced and are still looking for great solutions in. You have to secure your share, you have to record its purpose, you have to make sure you don't lose it. If you're using a threshold signature, though, which Frost allows, you're also going to get advantages. It's going to be more resilient, meaning you're not going to necessarily suffer loss if you just lose one share. And it's going to be more secure, meaning you're not necessarily going to allow someone to steal it if they just get one share. So, yes, we have the typical key management issues, but by using a threshold signature, we hopefully are offsetting some of them. Okay, just quickly to show signing here. Signing, again, this is using the ZF Frost D server. Um, you need a coordinator, which Frosty is, else the process is just too complex to manage. Um, but again, we can see there continue to be UI shortcomings because that's always been kind of one of our issues in the industry, how to make this really approachable to people. The one that I find here is that message to be signed. If you see there's a hex encoded blob here, and it just does, there's no necessarily easy way to see what it is. Maybe it's a message I could unencode, but maybe it's actually, bits for a Bitcoin transaction or something. We need to figure out how to make that more obvious too, so that people can sign in a rational way. Um, okay, speaking of Bitcoin, um, as I said, we have an example that Wolf put together of how to actually sign Bitcoin transactions. And this shows what's involved, and it's somewhat complex. It's a nested um, process. On the very outside, which is marked in gold here, we have the Bitcoin methodology, which is we need to create a PSB at the start and we need to transmit a PSB at the end. And inside that, which is in dark blue, are what we added to the process uh, because there weren't tools for these, which is we need to extract a SIG hash from the PSBT because that's what we actually signed, the SIG hash. And at the end, we're going to need to put the signature back into the PSBT. And in the middle of that, in the light blue here, we have what ZF Frost actually does. We initiate that coordinator, probably Frosty that I showed you. We actually have some number M people sign it. We aggregate those signatures. And then, as I said, we put it into the PSBT and we transmit it. But that's what the whole process is. And that's why we needed to create tools to make this all work. Okay, so that's Frost in a nutshell. We've spent the last 2 years evangelizing Frost primarily through developer and implementer meetings. The Learning Frost course, with the tools we've created for it, marks the next phase. We're now more directly supporting Frost developers with reference tools, demos, and a hands-on course that show how Frost works. This is a lot of what we try to offer for a lot of the work we're doing. We think the advantages of Frost are powerful, and we hope you do too. And we've got more that we're planning to do. So we want to show more use cases for Frost signing, and we're doing that with updates to two of our CLI tools. We have Guardian envelopes and we have our new Guardian clubs, and we're going to be able to show signing with Frost with both of them. But I think much more exciting are coordination examples. We want to resolve those coordination issues we highlighted here. How can we offer the UI benefits of coordination without requiring some level of trust in a centralized server? Our answer for that is Hubert, our drop-dead hub, which allows content to be dropped and then recovered using decentralized storage. We're already doing work on that, and we're just going to have a live demo of using it to do Frost DKG and signing next. We feel like this is really innovative work that is really not like anything else that we've seen there, and so we're hoping is a great advancement for Frost. So that's it. Anyone have any questions?
I wanted to raise up one particular point. I see we have some people in the identity side of the community. Um, I have written about the opportunities to do something called edge identifiers and clicks in a couple of articles. And the basic premise is that, our single signature paradigm is kind of limits how we approach and think about identity. One person, one key that they very, very carefully protect, et cetera. But with Frost and some of these other techniques, music, et cetera, there are real opportunities to be thinking about things in a different way, including edge identifiers and group identity. Um, and then for the wallet developers that are our guests today, there's a lot of opportunities around sort of hybrid things. We tend to think about multi-sig in the person of in from the point of view of multi-person, Alice, Bob, Carol, Dan, etc. But any one of those could be a device, an SD card, a smart card, excuse me. Um, could be a service, could be a social colleague, or it could be a bank or some other trusted institution. And we can take advantages of the heterogeneity of these different types of things. So I think there's also a lot of interesting things where we begin to think about security and identity and how we have no single points of failure, no single points of compromise or design by with tools like Frost that we really never had before.
Yeah, I think maybe edge identifiers we should talk just a tiny bit more. The idea behind edge identifiers is that identity isn't really just about me on the internet. It's about us. It's about relationships. And so Christopher and I have a relationship, and an edge identifier would be a kind of link that shows that. And we could have a frost group that is the two of us that would allow us as our relationship to sign things on that. But it becomes even more powerful with click identifiers, where you could have a whole bunch of people in a group that, together form the identity for that group, organization, club, whatever you want to call it. And with frost groups, we can have a whole bunch of people sign. We can have a threshold of people sign, and no one who looks at that signature is going to know that it is any different from any single person's signatures. So that means that the click or the edge, the relationship, it looks just like a single person on the internet, despite it being our collaborative power. So it's another great use case that should have been on my slide there on it.
Any other questions about the basics of Frost or what we're trying to do with our courses and or about why we're doing it on the command line to start?